No, they're not.
All right, notice we are not starting with number 9. We're starting with number 4. That's what's on the board. I've said it multiple times.
I did not get
Number 9 is what we're going to do after we get to number 4. Nope, we did not.
I don't like
Did I get a favor?
Oh, I wasn't ready
At
yet.
least I'm pretty sure we didn't.
Oh, we didn't. We had the talk. Yeah, we didn't finish it.
Yeah. This is like attempt number 5 at number 4.
Could you please pass me the whatever stapler is in there? I have stapler in Spanish. Is that
Hey, I never said that he was.
Sacapuncha? No, that's
I think it's
Salvador.
That's right.
No, not the cool.
Wow.
Grappadora. Yes, you are right. Being in this class is cool and unusual. This is the same packet that we've had, which I have a right. So I have a right to not be here. No, 4.
All right.
I thought we finished that one.
Oh, we've been over this.
Yeah, 45 minutes.
Ready to catch. Oh gosh, no, Shelby. So what paper are we doing? Number 4.
All right.
Taylor, we get it. You're cool. You're like, we get it. Your picture.
We get it. You have
Numbers line 4.
I'm not even wearing them.
Okay, I can't hear Michaela, and she's right in front of me, and she's very quiet because she's very sweet, and she was sick yesterday, so I need to be able to hear
I
her.
need the staple.
Hello.
Stop.
Numbers between 4 and 9.
Mr. Mike told me to
Tell me
shut up.
for this packet is my number's at 4 and then you're saying 9.
Are you looking at page numbers, or are you looking at,
Problems.
Can I have this?
okay, problems, yes. So you should have 7 and 8.
Whoa, big boy.
Do you not?
One of your shockers.
Okay.
I read a book last night.
Oh my god, dude. I haven't read a book since Linda Lyman.
What about
You see, you're up.
Here's 7 and 8.
I'm a little bit behind. I probably should start with
You have all the rest.
No, I finished that. That's for
Great.
what we
And I
read.
hope,
We read
like,
that.
please cherish all these packets, because I found out that apparently I didn't save the packet that I made, and I had to remake it all again
I'm literally
tonight.
not going to share.
So I can make it review again, so don't
Can
lose
I need
them.
the stapler
I
back?
cannot print you a note.
Oh, then I staple. I
Is it
staple.
like 8 and 6?
Are we not doing
Why
warm up
isn't
for the
this
rest of the
stapled? I
week?
just stapled.
I don't know. Probably not. Not in this
Okay, I need
lesson.
to turn that in.
All right.
Where is this staple?
Well. 7 a.m. dentist appointment.
Yes.
Doubt it.
No, literally, I
Like
was
these
at the
stories.
Where's the stick?
I'm sorry, I had a dentist appointment at 6 in the morning.
I literally just stapled
I
this
totally
and I
didn't
don't
just
know
sleep
where
in.
the staple
No, I didn't.
Wow.
Did I
Wow.
staple someone else's?
Liars always cough when they lie.
Has the sickness gone down since I've been gone?
Whatever.
Like how many
We
people
got 3 beverages.
ride home?
Like how many
And
people are asking? Oh my
I
god.
know. Does anyone know what flavor this is? Is this fruit punch or is this like cucumber?
He did 16, so.
Okay, well, listen, Dad, I'm eating breakfast.
Okay.
I just, you see, actually,
That's
see
right.
that it's
Let's go, it works!
that.
It works,
I didn't
everybody.
even know that.
This will help our sickness, but honestly, they should get rid of some more straws, because with one straw, you're gonna spread germs.
Yeah.
Right? I didn't think about that. Thank you for the hand sanitizer, but we need more straws. All right, anything.
Jamie was literally born in July. Yeah, Jamie doesn't turn 50
Yes. I feel like
Oh my
I need
god,
more
there's no
food.
more staples. That's why I didn't staple.
I have like,
Alright,
no,
let's
there's
do
not.
this.
More months. No, there's not. There's not.
Isn't it? Yeah, that I sort of. Oh, I got it. I got it.
All right, I'm starting.
No, wait, I can't concentrate yet.
D is the midpoint of AC. E is
I'm
the
bringing
midpoint
straws tomorrow.
of BC. We want to talk about these segments, and we know that these segments pertain to these triangles and these triangles. I told you yesterday that we're going to look at these two.
Didn't we do this one like 3 times?
Yep, I know. This is attempt number 3 of getting all the way through it for you guys. All right. I wonder why it takes us so long to get through it.
Why don't you just like save this? Can I have a new sheet?
Sorry, it's
Try to
really
not
gross.
write anything down.
So
Why
Taylor.
didn't you just save this?
So I don't have to write it all.
I'm so hungry. But it tastes so gross.
What?
Should I just
Jack.
not write
Apparently
anything
Jack
down?
is.
Yes. I mean, how many times do we have to write the same thing down for you guys to realize you don't have to write it every
I
time?
don't know.
Okay. All right, so here we go. Notice that we have a generic triangle, right? Random side here, random side there. It's not isosceles, it just looks like it. We're going to get these two triangles together, and the way we're going to do that is we're going to get this triangle on top with this triangle on the bottom. You guys should be amazing on this for the quiz. So notice, this triangle on top shares an angle with the triangle ABC. So again, here's the idea. Triangle on top shares this angle with the whole triangle. Everybody see it? Great. Awesome. Good. By shared angle angle C congruent to angle C. What?
We didn't do that yesterday.
Yes, we did. We did vertical angles at some point, but we might have done it first. I don't care. It doesn't matter. Order doesn't matter as long as you get the proof down. Now, some things have to be done in a certain order. Like you can't say off the bat, "Oh, look, the triangles are congruent." No, you can't do that. You have to show that their sides and angles match up, right? But like, whether you show the sides or the angles first does not matter. So, this right here allows us to say that, look, we have an angle in between two sides. So we should be looking for side angle side, right? And we do have that because if you notice, this side is half of this side, and this side is half of that side. So they are proportional, right? They both relate by half. So CD relates to the whole side, AC, the same way that CE relates to its whole side, CB. And not only do they relate, but we know how they relate. It's by half, right? Because this blue, that's one blue, that's half of two blues. This one pink is half of two pinks. So if this was 3, the whole thing would be 6, right? Guaranteed. And if this was 5, the whole thing over here would be 10. And notice 5 over 10 and 3 over 6 both reduce to a half. So no matter what these numbers are, they will be half of the whole thing. Does that check out? So these sides are related. So we've talked about two proportional sides, and we have an angle in between them. So we can use side angle side similarity. So we can say by side angle side similarity. The top triangle, which I will call triangle CDE, is similar to the whole triangle. So if C is what I said for the first triangle, this guy here, that's the purple angle, right? It's made up of the blue side and the pink side. If I look at my big triangle, I have proportional blue side and proportional pink side. It's going to go with C as well. Angle D on this top triangle is made up of the blue side and the unknown side, right? Proportional blue, proportional unknown is going to be angle A. E is made up of pink side and unknown. So if I look at proportional pink and proportional unknown, it's going to be angle B. Everybody cool with how I got those letters? Yeah? Okay, cool. So those two triangles are similar. Top triangle and the big triangle. So now that they're similar, I know that their parts are similar, so I'm going to say by CSP. And the parts I'm interested in are sides, right? So I'm going to get as much information about sides that I can.
Shelby's thirsty. Can I go get a drink?
Yes. We save the party juice for the game. Great. So we know that this side is going to be proportional with this side. Right? DE is going to be proportional to AB. Wow.
It still didn't show.
Are you with me?
Yeah.
Okay. So DE is proportional to AB. How do I know that? Because I can look and say that, see they are, right? DE and AB are in the same position, so they're corresponding parts. And corresponding parts will be similar. We also know that the other sides are similar. You notice CD and CA go together, which are the blue sides. Same thing with CE and CB. And if you notice from before, we know what these guys are, right? They're a half. So that means the green side must also be a half. So here's what I'm going to do. I'm going to put a midpoint here, call it M. I'm going to say let M be the midpoint of AB.
Wow.
Therefore, AM is congruent to BM is congruent to DB. Cool. Is everybody cool with that idea of I need to show that this is twice as big as that? So what I did is I put a midpoint down and did two
I
reads here.
don't really get that part.
Did you have
So-
to put the therefore part?
Yes.
Sort, like, I don't have that. I did that other thing yesterday and I did sort.
So, yikes. So the reason for this is that, see how this is 1 and then the whole side is double, right? So we go from this triangle being 1 blue to the whole triangle being 2 blue, right? 1 pink to 2 pink. So if I go from here, 1 green, it should go to 2 green, right? All the sides will be proportional. We said earlier that this is true, right? And so if all the sides are proportional, right, when I write them all, DE and AB will be the same as CD and CA, the same as CE and CB. And since we already know those are a half, this must be half as well. Remember, all the sides in a triangle, if they're similar, will be proportional. So if these relate by half and these relate by half, then this must relate by half. So let me show you up here. Now, do I have enough information to say that these two triangles are similar? No, I only have two sides. Right? So far, so good. They could be, right? 3 and 6 go together, 4 and 8 go together. They're both times 2, right? So I don't have enough information to conclude that they are similar, right? But if I told you they are similar, what must you know about these two sides, right? Then they must be similar as well, right? In the same way these guys are. So I don't have enough information right now to say they're similar, right? Shelby, you're with me on that? Right? I only have two sides that are proportional. I don't have an angle to go off of, so I can't do side, angle, side. I don't have all three sides, so I can't do side, 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 right? So I can't tell you they're similar. But what if the problem said, given that these are similar, what's this side? Well, 3 goes with 6 times 2, 4 goes with 8 times 2, so 5 is going to go with 10, right? You see how that works? If I know they're similar, then I know all their parts are going to be similar in the same way. So if I know that this triangle is similar to this triangle, which I do, right? I just proved that. Then I know that their parts should be similar in the same way. So if I go to their parts, DE and AB should relate, CE and CB should relate, CD and CA should relate. But notice I already know how these relate. So Shelby, if these relate by a half, then the third pair of sides should also relate by a half. Right? And that's what we're saying. So because these relate by half, I know this must relate by half. And the way to show that in my diagram is kind of hard. Right? Here I can just mark here and here, and now I've got double. Here, without the midpoint, how do I say that this is twice as big as that on my diagram? Right? The way I did it is I put a midpoint down, and I said, look, if that's 1 green, this should be 2 greens. Shelby, are you with me?
Yeah.
You keep zoning out.
Yeah.
Okay, but
I'm tired.
But is it better now?
Sure.
Okay, because I was trying to answer your question, and if I didn't, I'd like to go back.
No, you did.
Okay. Yes. Okay. Good. Again, not mad. I just want to make sure I can help. Okay. Good. All right. So we got sides, right? Let's get the rest of the things. I'm going to get this angle D in the small triangle, right? Must go with angle what in the big triangle? A. Now, angle A in the big triangle is this angle here, right? When I write that they're congruent, I can't call that A, though, and I can't call that D. See how there's multiple angle Ds in the diagram? Right? So what we're going to say is also by CSP, I know that angle CDE
Isn't there 2 angles?
yeah, exactly. So we need to call it CAB. You could have also called it DAB, right? Or even DAM. Damn, right? So, cool? So those angles are congruent. Now, could I do that for the other side too? Right? I could say that this angle is the same as that angle. Sure, right? Notice that angle E would go with angle B, right? And they're triangles. But I don't need that, because what I really want is to know about these triangles. And what those angles allow me to do is to say that, look, this segment and this segment should be parallel. See how they have a transversal here, cutting them both? And the corresponding angles are congruent. So by cap converse, right, these sides must be parallel. Right? Normally we say, if these are parallel, then the angles will be congruent, right? That's cap. I'm saying, if the angles are congruent, then the line should be parallel. That's cap converse. So I'm going to say by cap converse, that says converse. DE is parallel to AB. Now, I'm not going to extend these on my diagram for real because I don't need it for my proof. But you could extend this line right here. And then you'd have corresponding angles here and here. And then we could do vertical to this. Now, I'm not going to do that because I'm tired of doing cap and then vertical right after, right? Too many things. There's a theorem that says I can just say alternate interior angles are congruent.
AIA.
Yep, that's right. So I can say that this angle right here must be congruent to this angle right here by alternate interior angles there, right? If you look, what we have is 2 parallels and our transversal, right, DB. And you'll notice that this right here is congruent to this right here. That's what's going on. These are alternate interior angles. Do you see that? Okay. So I'm going to say by alternate interior angles theorem, I've got this.
Oh, no, I do.
See it now?
Yeah.
Good. It's kind of weird to see. If you need to, you can still do, look, cap down here, right? To say that these two are the same, basically, right? You draw a little line here and the other, right? And then do vertical to get that. if you're not comfortable doing alternate interior angles if you don't see it, right? Go for cap and then do vertical. Is that cool?
Yeah.
All right. So I'm going to say that angle EDF is congruent to angle ABF. Okay? Those are my two angles in the diagram. And then lastly, or you could have done the first thing, right? I think we did the other day. We saw the vertical angles right away, right? I can say that these angles must be vertical. What color? Oh, this is green. So these angles are vertical, right? By vertical angle theorem, angle DFE is congruent to angle AFB. Okay? So those two angles are the same. And now look, I've got angle in my diagram, right? And so these two triangles must be similar by angle. So by angle similarity, triangle DFE, I'll call it, must be similar to triangle angle D. Whoops, sorry. Angle D goes with what in the bottom triangle? B, because it's red, right? Angle F, well, that's my green angles, right? So they're going to go together. And then angle E is the unknown angle, which is this guy. Notice that this angle right here goes with angle E, right? They're both unknown. We know the whole thing here is blue. We don't know what this much is, though, right? Turns out it's going to be the same as that by alternate interior angles theorem. Or now we can use CSP because we know the triangles are similar, right? So they're going to go together. Whoops. A. Cool. So yeah, E and A would be the same angle by CSP, right? But we don't care about that. What we care about is that the triangles are now similar, which means we can talk about their perts. So let's talk about their perts. Well, if they're similar, we know by CSP that DF should be proportional to what? BF. Let me zoom in. The same way that FE should be proportional to FA. And DE, enough.
I'm sorry.
BA.
Anyone that sneezes will be doused in hand sanitizer. All right, there we go. We should have an eye wash station in here. That'd be great. Like, I'm not a science room, but the things we do in here require an eye wash station. All right. Yeah, don't touch the straw. People drink from that. All right. So we know the sides will be proportional. Now, if you look, I didn't do it in color.
Cut out the middle part.
But, no, hold on. We know DE and AB, how they relate, right?
Yes, ma'am.
DE and AB, it's written, BA, but it's the same thing. We know that this is our green from before, right? And we know that relates by DE to AB is half. Right? So that means all these must relate by half.
Correct.
Now they want it to relate by 2.
So flip
So we're going to flip them and get 2.
What? Wait a second. Wait, that's... And then we have to cut
Right? And then last step, we would just write BF over DF
I didn't even see that one in front of you.
equals FA over FE
I need the hands here.
equals 2. Right? And now we're done.
I don't get that, why you did that.
Okay, so you're good up to here? Or good up to here?
Yeah, I'm good up to that part, but
Okay,
then after that
so notice that DE and BA we already had was a half from earlier, right? And so all of this is a half? Okay, Shelby cannot handle this right now. She
I
has
told her to
zero
do that.
attention span.
Yes, I do.
I know we have.
Not in this
Not
class,
8,
but
it's 4. All right.
I have an attention span just not in this class because I'm tired. Okay, I get it.
vote we
Done.
not have this class right now.
Yeah, I don't like having the first hour this semester because I'm always tired.
First hour last semester was fun.
Yeah, now it's not fun.
I'm sorry.
It's just
I miss
crazy.
Gemma
Okay,
and Lane.
I'm listening.
I do too. All right. I had 6 hours though, so it works. All right, so here we go. You're good up to here? That's a half from before, right? And so what I did is I flipped everything to get 2 over 1. Right? So, Shelby, the relationship here is 2 over 1 because I flipped it. Right? You can say that this is half of this, right? Okay, shut up so she can hear me. DF is half of BF. We can say that, right? DE is half of BA. But can't we also say the reverse of that? That BA is twice as big as DE?
Yes.
Right? And so what I did is I flipped them and it changes the relationship to double, right? And that's what I wanted. That's why I did that.
So then
Right.
you just cut, or you just took out the
And then I
middle
took out the
thing.
middleman by transfer property. Right?
When I do this on the test, I'm gonna be so lost.
Oh wait.
I know, that's why we're doing it multiple times.
Oh no, you
So
took out the last one.
And then my grade's gonna be even worse than this.
Yep, I didn't need that. Only reason I needed that is so I knew it was a half, right?
Yeah.
And then once I had that, I said the rest are a half or double, right? The real property we're trying to express here and prove, guys, is that when you have a triangle, okay, here is the theorem that we're proving right now. You have a random triangle, okay? Look at this, very random looking triangle. Not necessarily right, but sort of right. Okay, if you take a midpoint, right? Midpoint 1, we'll call that midpoint 2, and then you connect them to their vertices. So if I draw a line from a vertex to a midpoint, right? And I draw a line from my vertex to my midpoint. And I could do that for the other side. I could put a point down and a vertex. It would intersect through here. They would intersect this point, which is kind of cool. They'll always intersect at a specific point. What we're saying is that this right here is twice as big as this right here. Always. So it could be 4 and 2, it could be 6 and 3, it could be 10 and 5, but this will always be true. And we've proven that because we know those segments. How do they relate? By double, right? This is double that. Always. Whenever you connect a midpoint, right? This is a midpoint, D is a midpoint, and a vertex, and another midpoint, and its vertex, they intersect at a point, and that point cuts this segment into half and double. Always. Will the numbers always be 2 and 1? No, they could be 6 and 3. They could be pi and half of pi, right? They could be any number, but they're going to relate by 2 to 1, that ratio. They're going to relate by 2, double. That's what happens. So this is really useful. We call these lines, we're going to be learning about this next week, these lines we call them medians. And the reason we, oops, I don't want to use blue, I want to use black. The black lines are medians. And we call them medians because they're connected from the midpoint to a vertex, right?
It's like the thing in the middle. That's a median. Yes.
Yep. This is a median, that's a median. Okay? So midpoint to vertex is median. I hear you, but I'm not hearing you. I'm purposely not.
I can hear you.
And this is one of the centers.
You walked into it.
I know. This is one of the centers of the triangle, and we call it a centroid. Or medicenter. That's what they call it in Eastern Europe. And I think they're onto something. Medicenter sounds like it goes with medians. Turns out that's the center of mass of the triangle, so the balance point. Yep. Medicenter, it's the center of the medians. It's the center of mass on the triangle. And again, the property is that the medians are always cut into 2 versus 1. So if this were 3, right here, then this down here would be 3 halves.
I had a fever yesterday, apparently.
Cool, cool, cool. All right. Let's back up and go over it again. How do we do it?
Like a dead cat.
Oh, number 5 times 5.
All right. Should we not go over it again? This is going to be on the quiz.
I just
It's
don't.
right there.
I don't know.
I just don't
You
get
seem a little
it.
angry.
I want
It
to
just
go
doesn't
over
make
it
sense.
again.
Great.
You grab?
All right, gentlemen in the back.
Yeah.
A little bit quieter. Bo, your voice carries, and they're really annoying. So when you talk to them, then they talk more, and then I can't, right? It's not your fault. It's really them.
Understand.
All right? So
I'm just, they use my
notice. So here's what we did. We got the top triangle similar to the bottom triangle, right? The big triangle. We did that by SAS similarity, so we had to talk about their sides, right? Because that's the S's in SAS, and the angle in between them. Then after we said they're similar, we got their parts the same, right? So we said this is going to be half of the bottom, and those 2 angles are congruent. If I know those angles are congruent, then these must be parallel. And then I can say that these angles are alternate interior. By vertical angles, now I have 2 sets of angles in these triangles that match, so these must be similar. If these triangles are similar, then their parts should be similar, so all their sides should relate. Well, I already know that one pair of their sides relates by half, right? So that means all the other sides should relate by half. So I can mark my diagram like this. Those are midpoints. We'll call them T and S for no reason.
Wait.
For Taylor Swift. So that means,
Or touch this.
right, this is twice as big as that. And this, 1, 2, 3, 4, 5, 1, 2, 3, 4,
Wait,
5,
what is this?
1, 2, 3, 4, 5. Those, that's twice as big as this. Guaranteed. And that's it, we're done.
I like understand what you're saying, but then like when I'm gonna have to do it by myself, I'm
Yeah,
not gonna be able to do it at all.
Well, the good news is it'll be the exact same thing, right?
Like I could tell you everything, but like someone else would have to write it down.
Yeah, like look at all that writing.
Can
can't
I just
do
like
all that.
get the test and then like record myself and just talk myself through it?
Sure.
Are you serious?
I don't care. Why is writing the way we have to do things? Because it's easy for me to grade it,
Yeah,
because I can
stupid
look at it.
writing.
But like, you could do that. I don't care.
I'll do it.
Guys, I don't care.
Listen,
Listen, guys, I don't care. Yeah, exactly. But if she talks me through the proof, that's the same thing as proving it.
Hello, welcome.
So, guys, spoilers, I don't care how I assess you. This is the term we're supposed to use, right? To see if you know this crap, right? I don't care how we do it as long as I know you know it. Right? If the test, the reason we use tests is because it seems to be the easiest way to get it done. Does it work for everybody? No. If you know a way that works better for you, let's do it.
There's nothing.
I'm not here to see if you can take a test. I'm here to see, do you know this stuff? I don't care how you show it.
Seth, I like your band.
That's
Sorry
always
for
my
where
problem.
you were waiting for them.
Yeah.
I know
I'm
what
not
you're doing,
allowed
but then when I get to the test,
Right.
I'm like,
Well, I know
ah.
they're brand new.
Dude, it's
It might also be anxiety.
Yes, exactly, right? And so however I can reduce it, I'd love to. I know that's a thing. So here's the thing. For this proof, it breaks down into a couple ideas. So ladies, oh my gosh, right?
I'm trying to think of a thing that I saw.
That's great, but like you're wasting your own time and then you're gonna cry about how stressed you are later and it's gonna
Oh
be
my God,
all
Taylor,
your
we
fault.
get it. You're better than us.
Okay, I'm listening.
All right, so
You have Invisalign.
this
I
triangle,
get it. You dated justice.
Shut up. They are dating.
I'm
Just
trying to
kidding.
listen.
Wait, they are.
I could just move on and I wouldn't be stressed about this.
Can I go
because-
sit in the back?
Shut up.
Yes.
I would not be stressed about this.
I'm shaking.
If I didn't know that you would be stressed about it too. And then it's going to be my job to walk you through it when you're stressed about it and crying over this quiz. So please let me do that now to save you stress. If you're not going to let me do that, I'm just going to move on. So this is your last chance. I will move on to the next thing if you're not going to pay attention. Because I'm doing this for you.
No problem.
All right, I'm going to move on to the next one.
No.
All right, nope, it's okay. It's okay. You guys don't have the attendance span for it anyway. It's beating a dead horse. Let's go on to the one I gave you.
Let's just get
9.
record again tomorrow.
Oh my god.
Are you?
You're not making this any better.
All right.
I don't know.
Stop.
Okay.
Dark. It's not. Have you ever been to Riverdale and in one of their science rooms they have darts everywhere, but they're not real?
They're staples.
Yeah, they're staples.
All right, I'm doing it. AD is the bisector of angle BAC. So what that means is that this angle right here is cut into 2 equal pieces. That's what that means. We're going to prove that AC relates to AB, AC and AB, and CD relates to BD. Now, here's the catch. These triangles are not similar.
So what happens?
Exactly.
Are they?
So here's what we're going to do. We're going to construct a line that is parallel to AD. So let there be line parallel to AD.
You could do that?
Yep. You can always construct a line that's parallel to another one, right?
That is so
That line is so straight.
Yeah.
Literally so bad.
So impressive.
Let's call it
Actually,
EB. I'm going to zoom out so you can see. Let there be EB parallel to AD. And then what we're going to do is we're going to extend this line right here. We'll call it X. Let there be CAX.
I do not have a number 9.
All right.
Anybody else taking notes?
what's that written down there? CA.
We created CAX as well.
Ah.
All right? So now that we've done that, you'll notice that we've created a bigger triangle, right? And we said that these are parallel, right?
Yes, it does.
Zed, shut up.
I want to say that all the time.
So these two are parallel. Now, as soon as I do parallel, we should be thinking about corresponding angles pasta. And look, check this out. Don't we have two parallel lines here and here? Which means that blue angle is going to be congruent to this blue angle by cap, right? You guys see it? Right? So by cap, those two angles are congruent.
Wait, are
Where did you
those?
put the point? Wait, I can't see. At the tip of the part right here.
That's A. Oh, that's E. That's X. That's E.
I was probably gassed.
So these two angles are going to be the same. Now notice that the big triangle and the top triangle share an angle. So by shared angle, those angles are the same. So now I can say top triangle is similar to the big triangle by double A, right? And if these two triangles are similar, their parts should be similar. And we're trying to prove that this right here, this side right here, that AC is proportional to AB, the same way CD is proportional to BD, right? Well, if this side right here is proportional to that side, AX and CA should be related the same way that CD and DB should be related. So these are proportional, right? What?
Are these two angles congruent?
Real early. 5 minutes.
Yes,
before
that was
class.
given to us, yes.
Okay. So then angle X is also congruent to both of them?
Yep, all three of those are congruent.
Okay. How do I know that the last one?
These two are given.
Yeah.
This is by cap. Yes.
Do you know what angle D is from angle similarity?
Yeah, you would. So you would know that these angles are all the same, right? Here and here.
Where?
Right? So those angles are the same, right? We also know that these should relate, right? This should be related to the whole thing as this is related to the whole thing. So we can write that down. I'm not going to do it because we don't have time. Zed, shut up. Like, don't talk. Not be quiet, but shut up. None of what you're saying is relevant to what we're doing, and it's annoying. Right? I know you don't want to pay attention because you're doing your thing, and that's fine. So here we are, right? These are related. Then we also know that these sides are related somehow. So I'm going to put a little squiggle mark to show that they're related. They're proportional. AD over BX is related, right? Now if you go back to our original triangle, we've got an angle here and an angle here. And then we have a similar side in between them. We know that these sides are related. So they're similar. And we know that these sides are related. So if you look on our original triangle, we've got two sides and an angle here. Angle, side, side, and we've got angle, side, side. So we've got asked, which is not one of our things, right? Is there a way to show, let me zoom in. Is there a way to show these two triangles similar?
So what side?
No, because they're not, right? So how do we get these sides and these sides matched up? We've got these two already. How do we get that and that matched together?
Wait, can't you
How
just
did
do
you get
angle,
that
angle
top
similarity, or you're not allowed to do that?
We don't have angle, angle. That angle's pertaining to the big triangle.
Oh.
It's not pertaining to that one. How do we get these two sides similar then?
Ooh, that's a good question. How did you get angle C? Could you do alternate interior?
I was just gonna say that.
Or what about AA?
That angle right there is the same as this angle right there by alternate interior, right?
What?
We have two parallel lines cut by a transversal. Those angles are the same. That's true.
It's not really. It's not really.
So notice, what do we have? What kind of triangles down here?
Isosceles.
These are the same.
So now we have.
So now, listen up. We know this side is proportional to this side, right? So shouldn't this side also be proportional to that side? They are the same,
Wait, how
right?
do you know they're proportional?
I'm going to say it again. We know those two are proportional, right? We proved these triangles similar by angle, angle, right? We had shared angle and then both had a red angle, right? This guy and this guy. by angle, angle. And we proved those two similar, right? Using CSP. So these two sides are similar. Well, aren't these two sides the same? So if that's similar to that, wouldn't it also be similar to this? So now we've proven that that side goes with this side and that side goes with that side. That's what we wanted. These two together and these two together.
Wait, so we just got that?
So here's what we did from the beginning. We got this triangle right here, similar to the big triangle. We did that by angle, 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 angle. You see it? If those are similar, then their part should be should be proportional. So that's proportional to this, and that's proportional to that. You cool with that?
Yeah, kind of.
Okay. And then we said, well, these two sides are the same because we have alternate interior angles, right? This is an isosceles triangle. If this is an isosceles triangle, these two sides are the same. So if this is proportional to that, it should be proportional to this side too. These sides are interchangeable. So by substitution, if that's proportional to that, this should be proportional to that. And now we've shown they go together.
I'm just confused about why you put the S's.
So S is showing you what's similar to what. So I'm doing this your way of just talking it out, right? These two are proportional, right? I could write that CA over AX, right, are related, right? Like that. That's my pink sides. And it's going to be the same way that CA is proportional to AB. Why do I know that? Because AX and AB are the same thing. We'll talk about this more tomorrow. Guys, I need more from you. I will admit that I'm not giving my best to you guys because you were my guinea pigs in this class because you were first hour. And I will also admit that I've been staying later trying to get all this homework graded that you guys turned in late, and so I was here until like 8 last night doing stuff still, right? And so I'm not getting here as early as I should to make sure first hour is great. But you guys are really just like not doing much of the time we have in class. A lot of it's just a giant waste. And that's fun, that's fine, and I like it. But you've got a quiz that's really going to stress the crap out of you guys on Thursday. And it's this hour I'm worried about the most. And it's not because this class is full of dummies, because it isn't. It really is not. It's because you guys just don't really use your class time well. I'm concerned. So this is what we'll do tomorrow. We'll go over it a second time, fully, when we do the review guide. This will be on the quiz, and you will need to extend your lines of